All right. Okay, so the next homework assignment, homework 11, is just a single problem. It's a very easy assignment. It's that homework problem 3 that was previously on homework 10. It's related to budget limitations. And so we're going to go over how to do those in today's in-class exercise. And so after today's in-class exercise, you can complete that single problem and submit it. I think you'll find it very straightforward. The project, of course, is due on the 20th of November, and I just wanted to point out that that project's worth 15% of your course grade. And so, potentially that's the sort of thing where, if you had a mid-A but then just forgot to do the project entirely, then that could take you down into C range. So you really want to give that the effort that it deserves and start to do your calculations early. And if you have questions, then make contact with me so that I can help you in any way possible. Regarding the exam, I've started to go through probably, I've been through 7 or 8 of those exams, but my goal is to have them scored by Friday of this week. And so it'll take me probably several more days before I complete grading those. What makes it a little bit complex is that, of course, there were more Microsoft Excel problems on this exam, and so it's not just a matter of looking at the PDF and seeing that you did it correctly, but rather I have to get into the spreadsheet files in a lot of cases and try and find out where the errors are when mistakes do occur. And so grading it is a little bit more labor intensive than it was for the first exam. So I'll get those graded as quickly as I can, but my top priority really is accuracy and making sure that you get the points that you deserve. Are there any questions related to the announcements before we start talking about capital rationing and budget limitations? Okay. Well, capital rationing is tied to the idea that every organization, including governments who maybe it seems like they have unlimited money, but they don't, every organization has a limit on how much capital is available. Craig asks if there is a length requirement for the paper on the project. No, I didn't specify a minimum required length on the report, but I do describe some pretty in-depth details on what I'd like you to consider. And so, a 2-page report where I'm asking you to go into a lot of detail on analyzing probable salary and expenses and the lifestyle you expect to have. I think that the length is dictated more by the topics I ask you to cover rather than just a minimum set length that I've specified. So back to the idea of capital rationing. Every organization has limits on the capital that's available, and you remember that we've looked at some figures that suggest the more money you borrow, the higher the borrowing costs get. In fact, that was a question from our first exam where there was that figure where the curve is going up, where the amount borrowed is gradually increasing. And so the reason for that, of course, has to do with the risk of default, where because if you've borrowed more money, then the payments will be higher, and there's a limit to the amount of payment that you're capable of making based on the income that comes in. And so whether it is a municipal government, a federal government, or a private company, every organization either has a fixed amount of money that they have ready for a project or money that they can go and access from the borrowing markets, because eventually the markets will become spooked if they think that a company is extended past its ability to repay. Now, I think I've mentioned before that I used to live over in the United Arab Emirates. I lived in an emirate called Sharjah, which is one of the 7 emirates in the UAE. It's right next to Dubai, just a few minutes from Dubai. And so while I was living there for several years, I would sometimes go into Dubai and I'd be blown away by the mega projects that are built and are under construction there. I'm sure that probably a lot of you have seen some of these projects highlighted on like National Geographic or Discovery or something like that. There's a lot of construction and development related projects on channels like that. And so on the left side of the screen here is an artificial island that was built called the Palm. And no, this wasn't just kind of a coincidence that it had that shape naturally, but it was just a normal coastline. And then through the process of dredging up sand from the bed of the sea and then piling up the sand and compacting it, that they were able to create this offshore series of islands and connect it to the mainland with a bridge. And it's really high-end housing that's there. Mansions that cost $5 to $10 million if you want to live on an individual home on one of these palm fronds or on the outer edge. There's a really big hotel at the end of it called Atlantis, and it's a really beautiful hotel and pretty expensive, high-end. There's a couple of skyscrapers, but it was a very costly project because the dredging units that are needed to create this offshore island are pretty expensive, and it requires a lot of engineering know-how. And so the development companies that's kind of owned by the Emirate of Dubai decided to move forward with this project, and they also built the Burj Khalifa, which is the tallest skyscraper in the world, very tall. But one of the proposed projects that was talked about a lot but never actually came to fruition was an underwater hotel. The idea was that they were going to try and put part of the hotel beneath the water and then build up rooms so that you'd be looking out of the window of your room at fish and coral and rocks. And I mean, it's a spectacular idea, but it was just not one of the projects that they were able to fund because the available capital was tied up in other projects at the time. So even really rich oil states that have access to lots of credit and there's a lot of enthusiasm do face this idea that there is a limit on the projects that you can actually undertake. And so trying to figure out, when you have multiple options, which of them to decide on is the outcome of a capital budgeting study. And in a capital budgeting study, what you're trying to do is develop a cash flow estimate, including what's going to be the cost of construction. And all of these projects are far more complex than some of the easy cash flow diagrams we've looked at in class, where it's a single lump sum amount at time zero. Building this offshore island was a project that extended across, I think, probably 5 or 6 years. It was a very lengthy process, and so constructing it is going to have a lot of outflows of cash up front, including preparing the site, like insuring it, advertising it, and so on. And then the inflows are so far in the future that there's a lot of uncertainty having to deal with developing what the probable income is going to be for the project. And so the first thing is developing for each of the projects an idea of the likely cash flow. And in projects like this, what we will assume, just for sake of simplicity at the beginning, is that you either accept a project or you reject it, but you're not going to build it halfway. So for instance, if this offshore island looked like it was going to be too expensive, then it would just be an outright no, and not simply that you're going to build only half of the island or half of the skyscraper. There are cases when we get a little bit more sophisticated with this analysis where we can have partial funding of a project, but in the in-class exercise for today and the homework assignment, it's either just a binary yes for the project or no for the project. And the budgetary constraint is the limit on capital that's available. And so what we'll do is look at different combinations of options. We'll have option 1, 2, and 3, and we'll find out if we do all 3, are we within the limit? If we just do 1 and 2, or what about 2 and 3, or 1 and 3? So we'll try and develop row by row a list of all the different permutations of different project combinations that we could have, and identify what is the budget that would be for each one of those combinations. We call them packages. So the objective in an analysis like this is to maximize the return on investment. It's not to do as many projects as possible, and it's not to have the highest interest rate that's possible, but it's to have the highest present value of profits. And so we're going to do present worth analysis at the conclusion of this kind of sorting and organizing process known as a budgeting study. One moment. I had to turn off the heater in my room here. It's kind of turning into a sauna in here. This figure comes from the textbook, and it's just kind of visually summarizing that if you have 3 projects, what you do first of all is you would try and identify what the construction cost, the initial outlay needed for each of those projects. And then you would put together a cash flow diagram over time, what the revenues are going to be. And the investment limit is just this known budget that dictates how much you can spend up front. And so you'd try and analyze every combination that's possible and find out among those combinations which is going to maximize the present value of your profits and still be within the limit of the budget. Now, these projects are considered as independent, which means that they can be done either individually or as pairs. They're not mutually exclusive. It's not the kind of situation where you can only do project A or project B. Each one of these projects can be done individually or with any group of the other projects as well. Now, sometimes that's not true. For example, if you have an investment company and you're thinking about doing projects in the same city, if 4 of the possible projects are like hotel developments, you couldn't maybe do all 4 of those hotel developments in the same city and get the revenues that you're expecting to be the same as if you're analyzing them individually, because you'd be cannibalizing the market. And so you need to be sensitive to the fact that it's possible in some cases that the projects aren't as independent as it looks like, because if you saturate the market with what you're going to be building, then the future revenues may be reduced. Okay, so bundling is a process of trying to identify how many different alternatives there are when we have a different group of possibilities. And so there's this calculation 2 to the m, where there are m projects. And so, for example, in this little illustration we're going to use for today's in-class exercise, we have project A, B, C, and D. And so that means that there are 4 alternatives. And according to this numerical model here, we have 2 to the 4th possible bundles. So that means 2 times 2 times 2 times 2. So 2 to the 4th tells us that there should be 16 possible bundles in this case. And so if you have the in-class exercise printed out, hopefully you do, what I'd like you to do to begin with is try out this 2 to the m and try and identify what are the bundles. So write the combinations in this space below. So just as an example of what a combination is. One combination of projects is A and B. Okay, so that's one combination. Another combination is A and C. Okay, then there's also A and D. Now, A and D is considered the same as if we said D and A. So it's not like D and A is a different grouping than A and D. It's considered the same. But what I'm telling you is there should be 16 different permutations of this. And so, one of them is going to be the do nothing possibility. So do nothing is one of the alternatives. And then another one of the alternatives is A and B and C and D. But then for a moment, I'd like you to see if you can identify all 16. So write them down and also number them to help you keep track of whether you can get all of the different possibilities. And then we'll look at it together just to make sure that you've identified all 16 of those possibilities. Okay, so if you haven't found all of the different combinations, let's look at it in a systematic way and see if we can get through identifying all 16 of the possibilities. So I'm just going to set this up in Excel because it's probably a little bit more neat than my handwriting, and also we're going to do some calculations later on. And so this is part 1 of the in-class exercise. And so let's say this is the bundle number, and then this is the combination. Here's the cost and whether it's possible. We'll get to the cost and whether it's possible a little bit later, but we're looking for 16 possibilities, and so I'll number them 1 through 16. And the first alternative that I mentioned already is do nothing. So that is a possibility, just none of them. Okay, now the first bundle out of this group of 4, we've got A, B, C, and D. So the first combination is, what if we only did A? I'm going to center this just for a little bit more visual appeal. Okay, so A only is a possibility, B only, C only, D only. Okay, so now the next one I'm going to say is, what if we did A and B? So that's a bundle. So A and B together. Now what about A and C together? So AC is a bundle, AD. Okay, BC, BD, and CD. So I've been through all of the single option bundles and all of the double option bundles. And what you remember I said before is that DA and AD are not considered distinct bundles, that those are considered the same group. It's the same 2 projects. You know, if you do A and D together, that just means that the 2 projects are being conducted jointly, none of the other options are being undertaken, and so it's not distinct just to refer to them in a different order. Okay, there's also A, B, and C together. So now we're moving on to bundles that include 3 options together. A, B, D is a bundle. A, C, and D is a bundle. B, C, D, and then all 4 of them. A, B, C, D. Okay, so there's 16 possibilities together there. Any questions so far? Did anybody find any extra bundles that I hadn't mentioned there? Okay, so that is part A here. How many possible bundles? There's 2 to the n, 2 to the m, where m is the number of projects, so 2 to the 4th, which is 16. Okay, now it's saying calculate the total investment required for each bundle. So that's the cost. We want to know the cost for each bundle. So the cost of the do nothing alternative is 0. If I remember correctly, all right, so here are the costs. So just for bundle A, it's a cost of $10,000. For bundle B, $5,500. Bundle C, $8,500, and bundle D is $15,000. Now, even though I know costs are negative, I'm still going to include the minus sign here because in part 2 of the in-class exercise, we're going to be calculating the present worth of the bundle. And so it will be useful to have the costs as a negative and the annual cash flows associated with each of these as a positive. So that's kind of why I'm bothering to leave the minus sign in so far for the costs. Okay, now for the rest of these, we're just going to be doing different combinations. And so A and B together is the cost of A and the cost of B. Okay, so do that same thing for each of these combinations. Go through the process of determining the cost for each one of them. And just to maybe make things a little bit easier to see, I'll format this as currency. And that way we have the comma there. The comma helps to see if we've got the numbers put in correctly. All right, so take a moment. Hopefully you're following along with Excel. Calculate the cost for all of those bundles. Okay, so I'm going to calculate the cost of the rest of these. Okay, so here is the cost of each combination, and the in-class exercise says that we have a budget limit of $23,500. So let me put that in here as our budget limit. I'll say B, which will stand for budget limit, is $23,500, and I'm putting it in as a minus simply because all of the other costs are minus as well. Now, I could just go through and type in a yes, no manually for each one of these. And so, yes, it's possible. Yes, it's possible. Down here, it would be a no because it's too expensive. But, it's better if we can set it up to calculate and determine that in an automated way rather than having to do it manually. So let's use an if-then statement to program so that it'll automatically compare the cost to what we know is the budget limit and then return an answer. It'll say yes or no depending on whether it's too high or too big. And so before we start typing in that if-then statement, let's just think about what's the logic we want to be incorporated in that statement. So we want it to say no, it's not possible if the cost is more negative than the limit. So since these are negative numbers, we're going to say if it is less than 23,500, then it's not possible. But if it's equal to or more than, because remember, if it's more than, that means it's not as negative, then that will be possible. So we'll give it a shot, and if it turns out that we need to make corrections, then we will. But we'll start off with if and a parentheses. And so now it's going to start to prompt us with what it needs to see inside of that function. So the logical test is the first thing. And so our logical test is if this cost, now what we said is we want it to be, if it's greater than the budget limit, then it's acceptable. Okay, so if it is greater than, okay, let's do it less than. All right, if it is less, because then we don't have to do greater than or equal to. So if it's less than that, then we want it to say no, it's not possible. Otherwise, we want it to say yes. And I always forget if it should be a single quotation or a double quotation in Excel, but let's give this a shot. Okay, so it's saying yes, it's possible. Okay, so promising so far. Now I need to anchor the reference up here to the budget limit, because as I drag that down, I want it to always look in this location. And so let me press the F4 button to put in those dollar signs and anchor the reference up to the budget limit. Okay, so it's saying yes, that is possible. And so now if I drag that down just by clicking in the lower right hand side, let's see if it gets the next one right. Yes, that's possible. What's the first one we think should be a no? It's row 12. So let me drag that down. Oh, yeah, row 12. So down here. Okay, good. It's working correctly. Oh, here was one as well. See, that's good. It's automated. It's doing it. So the reason why it triggered that is because if it is less than the limit, then it's no. So if it's more negative than our budget limit, then the answer is no. But if it's not more negative, that means greater than or equal to, then yes is okay. And the real test is we have this one is the budget limit. So 23,500. So that's saying yes, that is possible because it's right at the limit. And the limit is acceptable. But anything more expensive than the limit, it should say no. Okay, so let me drag that the rest of the way down through, and it identifies all the 3 and 4 alternative options as unacceptable because it's too expensive. Okay, does anybody need to see any part of what I've done so far? Did I move too quickly for anything, or would it be useful to see a certain function another time? You know, just because we're not too rushed, let me show you the other way we could have done this logic statement. So this logic statement was set up on the less than. Let me do it another way. So let me delete that. Okay, so the other way is if, maybe this will make more sense to some of you, if the cost is greater than or equal to the limit, and I'll anchor that reference now, then, okay, so if it's greater than or equal to, then yes, it's acceptable. Otherwise, if that isn't satisfied, if the logic test fails, then it'll say no. Okay, so it's saying yes, drag down through all of them, get the same result. So you notice I have the greater than and then also equal together, and that means greater than or equal to. So that's the other way we could have structured the logic statement there. Okay, so here are the ones that are possible, and we know that there are some of the options that are not possible. So this is part 1 of the in-class exercise. We have identified the feasible bundles. And so how many feasible bundles are there? Let me show you what maybe, instead of saying yes and no, maybe we should have it return a 1 and a 0, because then if we do it that way, then we can have it count this. So the sum, I must not drag that all the way down through. Let me return this back to 1 and 0. I'm not so sure why it's not counting those. Oh, it must be because it's returning that as text rather than as a number. Very strange. Well, let's manually count it then. How many possible bundles are there? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possible bundles. And so it asked, how many feasible bundles are there? There are 10. All right, so now capital rationing, part 2 of the in-class exercise here. We know that each project is 8 years long. Here's the annual cash flow that's associated with each of the individual bundles. And I give some suggested column titles that you could use. Bundle, cost, annual net cash flow, present worth of the bundle. Okay, so let me show you how we can apply this next part of it. Okay, so now we're going to move on to part 2. And our MAR, minimum attractive rate of return, is 12%, so 0.12. And N, number of periods, it said in that statement there are 8 periods, and then we have the same budget limit from before. Okay, so let's put together the bundle that we're analyzing, the cost of that bundle, annual net cash flow, and then the present worth of the bundle. I need to make this column a little bit wider. Okay, PW of bundle. Okay, so we're just going to only have the feasible bundles. And so they were A, B, oh, by the way, do nothing is a feasible bundle, but I don't need to analyze it. I already know that the present worth of that option is 0. So I'm not including it in this next analysis because I already know the answer. So the bundles A, B, C, D, AB, AC, BC, BD, CD. Okay, so is that, I must have missed one. Oh, there's also the do nothing, I guess. The do nothing. I'll include that down at the bottom. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, yeah, we got them all. Okay, so the cost of A is, I'll just refer over here. That's the cost of A by itself. The cost of B, cost of C, cost of D, AB, AC. I guess I could have just dragged it down because so far we're in order, except for now we're not because there's AD. So I wouldn't be able to drag down continuously through all of them. I just need to make sure that I'm only including the cost of the bundles that are feasible, CD, and then the cost of that one is 0. Okay, the annual net cash flow comes from this table. So let me just copy this and paste it so I can see it all on the screen at once. So these are the annual net cash flows. Let me move it here, it's a little easier. Oh, darn. Okay, so the annual net cash flow is $2,500 just for A. For B is $1,300. C is $2,100. $3,200 for D. Okay, now AB, it's the cash flow for A and the cash flow for B. So we're going to just find this is the annual revenue that's coming in each year for the combination of the options. A and C together, B and C together, B and D, and then C and D. All right, and then the do nothing, you get no money for that. Now the present worth, what we need to do is find the present value of this annual series and combine it with the cost. So the cost is already at the present. We want to find the present worth including the present value of this A and then also the cost. And so we're going to do the PV function using the known MAR as our interest rate, and N is 8 years. I'll anchor that reference as well. And now, this amount that we're going to put in, it's a payment. We're not going to put this into the future value field because if we put it into the future value field, then it's treating that $2,500 as just a single amount that's way out there in year 8. But really what it is it's 8 payments of $2,500. So we want to know what's the present value of that series of 8 uniform payments. And so I am going to put the amount here into the payment field, but I'll put the minus sign because otherwise Excel would change it. Okay, so far I found the present value of the income, and then outside of the PV function I'm going to add in the cost because we want to know the total overall present worth including the costs and the revenue. So if I do project A, then the present value of that is $2,419.10. And so I think I should be able to just drag down. Have I anchored my references? Yeah, up here to the top. Both of those are anchored. The other ones, as I drag down, it's going to look at the cost or annual net cash flow that's applicable just to that bundle. So I can just double click here and it does the rest of the calculations. And so then what do we do? Like, what's our objective? How do we know what's our objective here is maximize return on investment. We want to have the most dollars possible. So what would we do? Would we do just option D? Would we do C and D? This is the one that's the largest. Choose bundle AC. All right. If you have a really long list of alternatives, then it can sometimes be a little bit tedious to go through them and identify what's the highest. And so you could do equals max and then add all of these numbers into the range like that, and it'll identify what's the highest in this range of values. And so, once you know that the maximum profit is 4,351, then it can be easier to go in and find it. That's one way to identify what's best rather than visually, comparing all of them to each other. Another possibility is you can do conditional formatting. So if you highlight all of these and you go here to home, conditional formatting, and top, bottom, let's do a new rule. Okay, so the new rule is we want it to format only the top or bottom ranked value. So it will do the top one. So the top one means that it's going to select in this range whatever's the highest. And then the formatting that we could do is we could make it so that it's bold and maybe filled in yellow. Okay, so let's see what that does. So we've said it's going to bold and yellow the top one. So OK, and then you can see that what it did is in that range that we had selected, it kind of highlighted and identified the one that was the best. Can you do the present worth of the bundle again? Yes. Okay, so the formula is going to be, we are going to find the present value, the rate will be the MAR, NPER, number of periods, is 8 years. Now, this amount that we're putting into the PV function, annual net cash flow, what that is that's not a single one payment of $2,500. That is 8 payments of $2,500. And so we want to take those 8 payments to the present, which means that amount goes into the payment field. So we don't do the double comma here. Oftentimes we're using the double comma when we're discounting a single value to the present, but here this is a recurring value. So I'll put the amount in the payment field, not in the future value field. So that'll give me the present value of the revenue. And now I also need to add the cost to get the overall present worth of the bundle. So that's the highest for now. That's why it's bold and in yellow. I haven't done any of the rest, but then when I do, it'll change and highlight and bold the best of the bundles. Okay, so that is the in-class exercise. And if I quickly show you what the homework assignment looks like, I think you're going to find that there is a distinct similarity there. Let me see if I can get it real quick. All right, here it is. So you've got some options, 1, 2, 3, 4, 5 options. You're going to go through that same process that we just did in the in-class exercise. You're going to find out how many of the options are suitable based on the budget limit. Your budget limit is $8,000, and so you'll find out, can you do A, B, C, D, E for $8,000? Just by inspection, you can see, no, that would put you over the budget limit. So you're going to find all of the possible bundles, and then you're going to find out what is the combination of them that will maximize profits. So you're going to be using a MAR as 6.5%. You can see what is the useful life for each of these alternatives. And so when you're doing the present worth, then the projector, for example, is giving you $890 a year of revenue for 6 years, but then the van would give you more revenue but a fewer number of years. And so when you discount all those things to the present, be sure that you use the useful life that applies to each one of those alternatives. Okay, so I think you have everything you need to do that one problem homework assignment. which is due on Friday. Are there any other questions about this in-class exercise before we wrap it up for today? Well, okay, so that'll be due before 11 o'clock on Friday, and also the project due date. It's 18 days away now. It's due on the 20th of November. It seemed really far off when we weren't in November, but now we are. So hopefully you redouble your efforts and let me know if there's anything I can do to help you out on the project. That's it for today. I'll see you on Wednesday.